give you a little bit of insight into why I think that slide rule is cool.
Slide rules are cool!
Thank you! Slide rule is an analog computing machine. It was first developed probably by William OUGHTRED in about 1622. He was the first, at least, to put sliding scales together. These scales were developed earlier, about 20 years ago.
Could you use the microphone, please?
Oh, John Napier. Yeah, that better? By John Napier. Here's Napier. He was a Scotsman. And what you see to the right is a book of logarithms. And Napier's whole point in developing the logarithm was to come up with an easier way to do complicated multiplication and division. With logarithms, you can actually add, and by doing so, multiply, or subtract, and by doing so, divide. So if you have long lists of very large numbers that were coming more and more common as the scientific age started, then this was a good thing. You could rely on a table of logarithms, add some numbers together, and by doing so, multiply very complicated things. The slide rule, though, took that a step further. It put the power of logarithms into a portable device that scientists and engineers could use to make very close approximations of numerical calculations. So, for example, you might only be able to get 3 or 4 at the most significant figures out of a slide rule, but for most of what people do, that's fine. We have this idea with calculators that because we can see 8 digits or 12 or 14, that somehow that's meaningful. Wernher von Braun used slide rules to, unfortunately, develop the V2, but then later take it to develop the Saturn V and put man on the moon. The slide rule pretty much came to an end about 1974, because that's when a little thing called the pocket calculator that had scientific functions like logarithms came out by Hewlett-Packard. But until then, the F-16, the Apollo moon missions, lots of things in civil engineering like the Aswan Dam, the Hoover Dam, the Brooklyn Bridge, the Golden Gate Bridge, and so on, all done using slide rules, which could quickly multiply, divide, get logarithmic functions. I like this. About 1962. IBM, 150 extra engineers if you buy our 360.
Oh my God, that is killer.
Which is kind of probably true, but only in a very narrow sense. Here's the thing that killed the slide rule, the HP 35. Hewlett-Packard developed this and introduced it in 1972. It was called the 35 because it had 35 keys. And it didn't do a lot compared to what any modern scientific calculator will do, but it did about as much as a slide rule could do. And it could do it faster and, in some sense, more accurately. However, accuracy is sort of a strange thing. You can show 14 decimal places, but if you only have a factor that you know to 1 or 2 decimal places, like say, if I want to measure the height of a tree by my shadow that's cast, and I step it off by pacing, well, my accuracy is not going to be all that great. I mean, the best I can possibly do is 1 or 2 feet, but the calculator is going to tell me that it's 47.493278 feet tall, which is dumb. It isn't really true. Bottom slide rule has a 1/2. If you come over here, oh, sorry, too fast. At this point, I'm just offering eye candy. I'm showing you why these things are so darn beautiful. They had leather pouches, people wore them on their sides. If you were an engineering student at any major university or anywhere else, in say 1940 through 1972, you had one of those things on your hip. This one I bought years ago. This was a fellow named Edward Maddox who worked for the Texas Highway Department had this. This is called a Darmstadt style slide rule. And it's a beautiful object. I think, pick it. This went to the moon. Actually, the Apollo 11 crew used it to help make a course correction. They also used an HP calculator once to make a similar course correction. My favorite slide rule, the Post Versalog. It's made of bamboo, covered with plastic, and very finely engraved. And here we have Keppel and Esser, who was probably the first company in America to manufacture slide rules, starting back in about 1912. Beautiful Desset log, trig, log, slide rule. Yes, Mark?
How did they etch the little marks?
You know, that's
to
a
be
cool,
so precise and accurate.
that is a really cool thing. Well, Pickett, the company that had the slide rule that went to the moon, they made a printed, essentially a screen printed version, so they got away from having to do that. But before that, slide rules were marked very precisely with something called engine engraving. And an engine engraving system is something like a very, very precise lathe and that has, the same way that you can use a lathe to get 30 thousandths of an inch accuracy, you can do too with this engine engraving process. So they would lay down a coat of celluloid on top of the wood or bamboo or later plastic. And then the engine engraving system would be set up to program to go through and cut fine marks. And it would do so over and over and over again until you got all the marks you needed for each of the different scales. And then they would rub ink onto the rule in a printing process, and then run the slide rule through a buffer to buff out all the ink that was on the surface, leaving only the ink that was down in that finely engraved etching. And that's how you got nice, sharp lines. Yeah.
Has any murder occurred with that as the instrument?
Say that again.
Well, we're talking engineers here, so
Yeah.
has there ever been a homicide that had occurred where that was the weapon?
You know, that's an interesting question. There ought to be a play about that. You know, there's a wonderful play called Copenhagen that deals with Schrödinger and Heisenberg and trying to figure out the early days of what exactly relativity and then quantum mechanics meant. And it's a great play. So if you can do that, you can probably do one about slide rules too. I like it. Thank you all.